Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 11 in our incredible new tutorial series where you're knowing where you're going with your ultimate GPS tracker project. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. I will also need you to get out your most excellent GPS tracker project and get ready to learn some cool new stuff. So what I'm going to do is I'm going to show you two things today, and these two things are the solution to the homework that I gave you in lesson number 10. But I must start by asking you, were you successful in doing the homework assignment from last week's lesson? If you were successful, leave a comment down below. I am legend, double chest bump. And if you weren't successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. But hopefully most of you guys were able to get this because it really was a combination of things that we'd already learned in earlier lessons. So the first part of the assignment was to go in and look at the NMEA sentences and find altitude, pull off altitude, parse it, and get it into your dictionary as a parameter, like the GPS data of index alt would give you then the altitude. Okay, that was the first thing. And then the second thing was that if we look at our existing project, we'd already kind of filled up the OLED screen. And so I told you to add two buttons, okay? And then what we were going to do with the one button here, that we're not going to use the second button today, but I thought let's go ahead and get it hooked up. And this is connected to GPIO pin 12. This is connected to GPIO pin 13. And then we have this configured as pull up resistors. You need to activate the pull up resistors because what we have is we have these connected to ground. Okay, and if we're connecting to ground, then we have to activate the pull-up resistors on those pins that we're reading the buttons from, which are pin 12 and 13. Okay, so I don't think I need to show you the schematic on this. It is on toptechboy.com if you want to go find it. But with what I just told you, I think you should be able to get things done. Now, the second thing is we want to start where we left off with last week. And so I will need you to go to the most excellent www.toptechboy.com, and we want to start where we left off with the code last week. And so you can use this happy little search tool here. You can search on something like getting UTC atomic clock time and date from GPS. Search on something like that. You'll come here. That was the schematic with the buttons. I just told you how to add the buttons. And this is the code that we ended up with last week. So I'm going to copy that, because some 100 lines of code, we don't want to type that in again. We want to pick up where we left off. So I'm going to paste that here. Wow, we're up to something like 150 lines of code. Okay, so yeah, we don't want to type that in again. Now let's run this and make sure that the universe is in proper working order and that we can simply copy and paste. And so if I run this, it is giving me some junk, and then it is now running. And then if I look here, you can see that I'm getting the data on the OLED, and I can see that the clock is updating and the numbers are updating. So things do seem to work as we would expect. And then if we come over here in our shell, you can see in our shell we're getting updated data. We have a wonderful number of satellites of 10, which is really, really good. And again, you can see up here the time is updating. So everything is copacetic at this point. All right, what was your assignment? We want to add altitude. We want to add altitude. Well, the first thing we need to do is go up to our dictionary, right? This is our dictionary. The last thing we put in our dictionary was date. So we need to put a comma there because we are now going to add out, not lat, out, like that. Okay. and then we're going to come over here, and I'm going to put it at 0.0. I'll show you in a minute why I am using 0.0. Okay, so that should be good. Now what we want to do is we want to kind of find where that altitude is in the NMEA sentences, and I know where it is, but I just want to show you how I kind of work through these things and figure them out. So what I'm going to do is down here in our thread, the GPS thread, we come down and in this keep running, and then we read these NMEA characters, we read the characters and we add them to the NMEA sentence. And when we get to the /n, the end of line, that means we're at the end of the NMEA sentence. And then I create the my_NMEA that's cleaned up by doing this my_NMEA equal my_NMEA.strip. And then what we are going to do here is we are going to print my_NMEA, because we want to look at that. We want to see if inside of there we get some insight as to where the altitude is. Okay, so we're going to run it. That looks good, and we're getting NMEA sentences. So I'm going to terminate the program. And if we come in and look at these NMEA sentences, do we find anything that looks like it might be altitude? Okay, yes we do, because if we come in and look at this GPGGA sentence, we see over here something with the M as in meters, okay? And then right before that, we have this number 1,140 for me, which is my altitude. Well, I think really we should say elevation, and I guess we should make sure that this is clear. Whether you call it altitude or elevation, there's probably purists that are going to tell me what the difference is and why it matters a whole lot. But whether you think of it as altitude or elevation, this is your distance right now of your GPS above sea level. Okay, so I am 1,140.1 meters above sea level, which means where I am sitting on the ground. Okay, so the ground level is 1140.1. Now, if I got in an airplane and took off, this number would be higher. But if I want to know how far I am above the ground, I would take the number that I read in the airplane and I would subtract this number, and then that would be my distance above the ground. Now, if you're really doing this, the challenge becomes as you fly, the elevation, the ground elevation above sea level is 0. So you've got to be kind of careful, because you might say, I'm 50 meters above the ground, but if you're at a different location, you might already be on the ground. Okay, if that makes sense. Okay, so we added alt. And then we've added out to the dictionary, we have found this number, which seems to be the one we want. So it's in the GPGGA sentence, and it is at the 0th, 1, 2, 3, 4, 5, 6, 7, 8, 9. It is in the 9th position. Okay, so now we need to grab it. So we're going to come down here to Parse GPS. Okay, and it is going to be a whole lot like this. Okay, it's going to be a whole lot like this, because this is getting from GPGGA, the first position. It's going to be a whole lot like that. And so what we are going to do here is we are going to say GPS data of what did we just get? We got alt. All right. And now what is that going to be? It is going to be this, but it is not the first position. It is the 9th position. And then we know that this is going to be a string, but we want to save it as a number. We want to save it as a float. Okay. Yeah, I will also tell you that this is in meters. If you want to change it to feet or yards, you could do your conversion right here. I'm in meters, so I'm going to report in meters. That's absolutely fine with me. You can do a correction here to turn it either into feet or yards if you prefer. Okay, so that looks pretty good. Now we need to come down to our print. And then what I'm going to print is, I think that above the sats, what I'm going to print is print, and I'm going to put elevation, like that, space, and then what is this going to be? GPS data of out, like that. Okay, like that and like that. Okay, could it really be that easy? Now I want to take that print NMEA out because that'll really mess us up. I'm trying to read this as it goes by. So this was useful, but no longer needed. Okay, and let's make sure we stop the program. So I'm going to do a Control-C. Okay, and this, hopefully, yeah, that's already stopped. All right, so now let's run this thing, and we get our junk, and then we wait, and now we are getting live updated data. And what do we see here? I need to raise this up a little bit. What do we see? We see that we are now getting elevation, and the elevation is 11.39.6. Now, I want to show you something that I've just observed with this, that of course time updates frequently, lat and lon update frequently, your knots updates frequently, but the heading and the elevation seem to update slowly. Okay, so you see, it's not that we're not reading these things incorrectly, it's just that they're sort of being updated slowly. Okay, and I'm trying to think if there's a way that I could really show that. What you could do is, I'm not going to slow down because we got a lot more work to do. You could go in and you could print out the NMEA sentences, and you're printing out the NMEA sentences. You're going to see that this heading and elevation doesn't seem to update itself as fast as the other ones do. I don't know if we were actually changing. If it was changing quicker, it would report more frequently, but it just seems like that these remain somewhat stagnant for a while. Okay, just an observation. Okay, now we are going to do a Control-C. Now there's one other little bit of bookkeeping that we need to do. As I was going in and adding these buttons and adding these other things and making the program more complicated, I started seeing unusual behavior in the GPS, like the GPS would just stop working or partially work or work in an unexpected way. And like I couldn't cleanly get the things to work the way I wanted them to work. And finally, what I found is not only did I need to unplug this, but I needed to go back to the back and take the little battery out and kind of do a hard reset, and then the GPS would start working again. Now, what's the problem with that is I want to move forward with the project. Now I've got to wait another 30 minutes or an hour for this to get a fix from a dead cold start. Okay, I don't want to have to go back to a dead cold start because then it takes 30 minutes to an hour to find a fix. So what I found was that we can put a command in the program that we send to the GPS that just sort of tells the GPS to restart. It remembers its almanac of the satellites and where everything is, but it seems to kind of clear the UART and kind of clear its head and get things back to a, kind of like a normal condition, if you will. So what we're going to do is we're going to come up here where we define the GPS. Where did we define that? Here it is, right here. Okay. Now, what I am going to do after we do that, I am going to send a command. And I'm going to paste that command because I don't want to fight with trying to do this perfectly. But you can stop, pause the program, and type this in. You have to do it exactly. But what it is a GPS, that's our object.write, and then you have B for byte, single quote, $PMTK, uppercase all, 314, comma, -1 star 04 /r/n, end quote, and then end this. And what that does is that sort of reboots your GPS. And since I put this command in, I haven't had problems with the GPS getting lost or confused or me not able to restart things. And so there's all types of commands. There's probably 1 or 2 dozen commands that you can send the GPS that does different things. I'll probably in the future go over those commands and help you see how you can configure the GPS from your program. But for right now, let's just say you need to do this one. Okay, so that's something. Now what do we need to do? The problem is that if I run the program again, the problem is, okay, let me show you something that's interesting. I just saw something. In our junk that we printed out this time, you saw that we got something new in our junk. And that new thing that we got was this thing we've never seen before, which is this, which seems to be reporting back to us that it wrote this. It seems to be reporting back to us that it wrote this to the GPS, okay? It seems to be giving us that back. And so let's do a Control-C. Let's run it again. Okay, and there it is. You see, and if I go in and look this thing up, this response that we get back, if I look that up, it probably would tell me that it received the GPS sentence. I can't do that right now, but just take my word for it. You want to send that command, okay? And we'll talk more. If I haven't said it perfectly, we will talk more in a separate lesson about this in the future. Okay, but now if we run it, if we run this thing, then what is the problem? I want to print something else out on the OLED, but the problem is that I've used up all my space. And so what I need is I need now to be able to toggle between 2 screens. All right. So in order to do that, what we need to do is get this button working as a toggle button. Now, there are a lot of ways that you can do a toggle button. But as I started looking at this, it was a little bit trickier than what I had initially imagined, because certainly you don't want to do the toggle switch in the GPS thread, because at a baud rate of 9600, it is all we can do to keep that UART clear and to keep the data coming in cleanly. So we don't want to mess with this thread. This core will only be working on reading the data and nothing else. So if we can't do it on this core, we've got to do it on the other core. But if we come back to the other core down at the bottom, where it's the kind of main while loop here, the main while loop, what we do is we get the data and then we see if we have a fix. And then if we have a fix, we print all this stuff out. Then we display it on the OLED, and then we wait a second or two, or we wait some amount of time until we display it again. Well, what is the problem? If we're going to be using this button, we have to watch that button constantly, right? We have to be constantly reading it. So if we do it in the main loop, this thing is going to mess the timing up. Well, then what we could do is we could create these timers, and so we could do a start time, and then we could see after every so many we could come in and look at that, and timers, it seemed difficult to do it. And so what I decided to do was the best way to do this was using interrupts. Okay, now I told you that the prerequisite for this class was my earlier class, Raspberry Pi Pico W lessons for absolute beginners, and in that class I showed you how to do interrupts. You should know how to do the interrupts, and that's how we're going to do it, because it doesn't interfere with the main thread. It doesn't interfere with the other core that's doing the loop with the reading and displaying the data. And so the easiest way to do it is with interrupts. I will be honest, I was sorely tempted to do it using the state machines because we had all those lessons on state machines. And if you guys did that, that would be absolutely great. But I did not want to make you weary, so I decided let's do it with interrupts. Okay, and if you want to learn about interrupts or review interrupts, go back to Raspberry Pi Pico W lesson 84, in which lesson I show you how to debounce push button switches using interrupts, and that is exactly what we want to do today. Okay, so let's go in and let's do that because we want to get that button working. Now, in the end, what the button is going to do is it's going to toggle between two different screens, but the first thing that we've got to do is we've just got to get our toggle, our basic toggle function working, and then it's easy to have the screens toggle once the toggle buttons are working. Okay, so I'm going to start with this left button. Okay, and where did I say I had that connected? I said that I had that connected, and let's make sure that I'm in the right spot here. Okay, yeah, this is the main while loop, and before the main while loop, okay, so this display show is the last line of the OLED display function. And then before we start the thread, right, before we start the thread and back dedented all the way over, this is where we want to set up our toggle buttons. So I had told you that but one pin, that's the one on the left, is connected to GPIO pin 12. Good. Then but one, the object is going to be equal to the pin method on but one pin, and it is going to be a pin.in, and then it is going to be a pin.pull up. So we are activating those pull-up resistors so that we can read from it. All right, so that's good. Now we have got to set up some variables, right? The first one is going to be but one up, and that is the last time that we measure where the button went from down to up. So when the button goes from down to up, that time we're going to store in but one up, and we're just going to initialize it to 0. And then similarly, what I'm going to need is but one down. Now you can go back and watch this in that lesson 84 because I don't want to slow this lesson down too much, but I'm recording 2 times when the button is pushed down and then when it is led up. All right, when it is pushed down and then when it is led up. Those are the 2 things that I am recording. All right, so now I have the time of the button down and the time of the button up. Okay, so but one up, but one down, that looks good. Okay, now I'm also going to have but one old. All right, and but one old is the last time through the loop, was the button up or was the button down? I have to initialize this variable. And so since nothing has happened yet the last time through, certainly it was up. So but one old is going to be equal to 1, saying that last time through the button was up. Okay. Now, I am going to have to toggle between screens in a minute, so I'm getting off the topic of buttons, and we're going to be thinking that I have to keep track of whether I'm on screen 1 or not. So I'm going to say screen 1 is equal to true. So the first time through the display, it will display things on screen 1. Okay, now what I need to do is I need to set up the interrupt. So when this button is pressed, I want it to raise an interrupt, and then that interrupt will send it to a function. So I want but one, that is the pin, that is the object, right? .irq for interrupt request. And then what do I want to trigger on? The trigger is going to trigger on the pin. Which pin? The pin associated with but one. and then it is going to trigger on IRQ underscore falling. Okay, because if I go from a 1 to a 0, if I press the button, I go from a 1 to a 0, I want to trigger the interrupt. Okay, but I also want to trigger the interrupt, so I will say an OR, that is a shift and the little thing that is above the enter key, that OR. So I want to trigger on pin.IRQ falling, but I also want to trigger on pin.IRQ rising, like that. So why do I want to do that? Well, in order to debounce the switch, I want to know, when did the switch go down and when did the switch come up? Okay, so I record the time. Let's say I pressed the button earlier. I want to record the time that I release the button, and now I want to record the time that I press the button. So I want to activate the trigger. I want to activate the interrupt either when the button is pressed or when the button is released. Does that make sense? Okay, so that's what triggers it, but now the question becomes, whether you can see this if I keep typing, the question becomes, what do I do if I get an interrupt? Well, my handler is going to be equal to but1 IRQ for interrupt request. All right, so that's very good. Now, what is my problem? My problem is that I have not defined this. So I need to come up here and I need to say define. And then what am I going to define? I am going to define that function, but1 IRQ, my handler that I'm calling, and I'm going to pass it the pin that is associated with the interrupt. Now, I don't think we actually use it, but I'd just like to have it in case we decide to do something with it later. Now, what do I need? I'm going to use global variables. I need but1 up. That is the time when the button went up. I'm going to need but1 down. That's the time that it was pressed down. And then I'm going to need but1 old. That is last time through the loop, was the button up or was the button down? And then also, right, we're going to toggle that screen 1 between true and false. We're going to need screen 1. Those are all the things that we are going to need here. All right. Now, what we're going to say is but1 value, that is this time through the loop, what is but1 value? It is equal to but1, my object associated with that button pin, but1 dot value. Okay. Now, what do I have here? I have a but1 value. So now I think I'm just going to print but1 value. Okay, and then before I forget it, what I'm going to do is remember that now but1 old is equal to but1 value. I always like to put this in because we always forget to put that in, and then we waste 30 minutes debugging. So let's see if this will even run, and let's see if we can get it cleaned up and so forth. So we're going to run it, and right off the bat, it doesn't like 131 define. What is that nonsense that I did there? What on earth was I thinking? That was crazy. Define but1 IRQ pin. Okay, what is that? It's equals 0. Okay, now the challenge is, did I really kill the thread when the program crashed? I don't know, but let's see now. Okay, we're running, and okay, now we're getting data. All right, now let's just see if it sees a button press. Now remember, this is not debounced, and so it might give a lot of, what did we print? But1 value. Yeah, so let's see. If I press it, I get a 0, and if I release it, I get a 1. I press it at 0 and I release it in a 1. So it is, I am talking to that button. Now, if I kind of move it around, you can see that there's a lot of bounce in there, and we would expect that. But now we're going to go in and we are going to debounce the switch. Okay, so now we've got our but1 value. I'm going to not print that anymore. And what do I need to do? Okay, if but one value equals 0, what does that mean? That means, how did I get into the loop? I got into the loop because I pressed the button down. Okay, so if but one value is 0, that means I got here because somebody pressed the button. Well, if somebody pressed the button down, what do I want to record? But one down, and that's going to be equal to time dot ticks underscore milliseconds, like that. Okay, so now what do I know? I know at what time the button was pressed down. Now, what else do I want to know? If but one value equal 1, then I got into this by what? By releasing the button. And so in that case, what would I want to record? But one up. And that is going to, not titches, ticks. Doesn't count as an error if you catch it before you run it. So but one up is going to be equal to time dot ticks underscore milliseconds. Okay, now this, you can go back and watch the lesson, but just listen carefully, because what you have to see is what counts as a button push. What counts as a valid button push, a debounce button push? Well, I push it and I release it, and then I record the time of the release. The time of the release is the but one up. That was the last time when I released it. Now this time when I press it, that is going to be the but one down. And what I want is, I want a certain long period of time between the last release and this down. And if that's more than, like 100 milliseconds, then I have a valid push. So I'm looking at the end of the last button push to the end of the last button push with the release. Between then and this button push down, I want that to be a certain amount of time, and then I'll say I have a valid push. If you want to understand it better than that, go back and watch lesson number 84, because we saw this was the most reliable way to debounce a switch. So now, do I have a valid button push? Well, if but one old equal 1, that means last time through the button was up, not being pressed, which is a 1. So last time through the loop, I had a 1, okay? And but one value, that's this time through the loop, is a 0. So if I went from a 1 to a 0, I might have a valid push. But what else do I have to check? And but one down, that was the that's what we just did, right? The pressing it down minus the but one up. That was the last time that it was released. I want that to be greater than 50 milliseconds. And this gets rid of the noise associated with either pressing the button or releasing the button. Okay, so if those things are true, let's see, but one old, but one value, but one down, minus but one up. Okay, that looks good. Now, if we do that, what things do we want to have happen? Well, what I want to have happen is screen 1 is equal to not screen 1. Not screen 1. So if last time it's true, this time it becomes false. If last time it was false, this time it becomes true. And then what I want to do is I want to print button 1 triggered. Okay, like that. All right. And then what we do is we do have this now making but one old, but one value. Does that look good? Okay, now this should be a debounced. This should be a debounced signal. So I'm going to run it. 138, what is this? Invalid syntax. if, what is it not like about that? 138. If but one old, equal. Hopefully you guys saw that. Okay. Now, did I kill the thread when that crashed? I hope so. All right, let's see. We get our junk. Okay, and now things are going along okay. Now I'm going to press and release the button. And what did we see? One notification of trigger. Also, if I press and release, you only get one notification. All right, so I'm going to press. And really, if you want to test it, suppress this printing of the GPS data and just look and see if every time you press the button, you get one print of the trigger, right? It only prints one time, and it only prints when you press down, okay? Notice I'm pressing down. When I let up, it doesn't trigger. All right, so we have a debounce switch. You guys can go in and test to your heart's delight, but that should be a very robustly debounce switch. Now, what do we need to do? The real issue is you can see that here we are already printing the elevation, but now we really need to go in and take care of the OLED. Right, we need to take care of the OLED display. And so we need to go back up and we need to find that display OLED function here. All right, so still if GPS fix is false, that's right, we just display text of waiting for a fix, that's good. Now if GPS data fix is equal to true, we want to do one of two things. We want to say if screen 1 equal true, we want to do one set of things. And that set of things we now need to indent. So I'm going to come up to edit and I'm going to say indent selected line. So these are under this. Then the other thing that we would do is if screen 1 equal false, like that, then we would do a different set of things. All right, now what we can do is we're going to have more spots here. So I'm going to come up here and at the top I'm going to say display text, and what I'm going to display is again our title, Ultimate GPS, like that. And that is going to be at the 0,0 position. And we got to close that and then close that. All right, does that make sense? Okay, what we also need to do is, because there might be a difference between this and this, we need to once again go in and just say display.fill with 0. And that way, this screen is not going to overwrite the second screen. So we got to set those both to display.fill with zeros. Okay, so we got that taken care of. Now, all of this is not going to fit on the first screen. And we also need to add the elevation. So what do I want to do on the first screen? I want to display the title, and then what do I want? I want to have the date and time, and then I want lat, lon, and the number of sats. So I want lat, lon, the number of sats, but speed and heading, I'm going to cut, and I'm going to put those on screen 2. Okay, I'm going to put those on screen 2. What else am I going to put on screen 2? I've got speed, I've got heading. I also want the title again. And let's see if we can get like the title and the date and all of that. Let's get both of those. All of that. The title, the date, the time. We're going to put those here as well. Okay. And so up here we have 1, 2, 3, 4, 5 lines. Here we have 1, 2, 3, 4 lines. And so now we have room for one more thing, which is display text. And what do I want to display? Altitude, like that. Close it, and then plus the string value of GPS data of what? Of altitude, like that. And then I want to concatenate that with the character space meter, like that. Okay. And now this is probably going to be like 0.46 here. And we'll look at that, but 0.46, that's just a guess. But now we've got to make these line up. 0, 0, that's good. Now this next line would be the next line, which would be line 16, right? Because we got to get out of that yellow region. And now we can go 10 at a time. This would be 26. This would be 36, and then this would be 46. And guys, if you just dropped into this lesson, I probably just confused you, but if you go back, I explained all this in detail when we were putting the OLED on. Now we've got to correct these. So I've got 0, 0, then this is going to be 0, 10, and then 16, and then 26, and then this should be 36. That doesn't sound right. 0, and then this is, I'm sorry, 16, and then this is 26, 36, and 46. 16, 26, 36, 46, 16, 26, 36, 46. Okay, let's come back over here to this view. All right, and let's actually run this thing. Okay, we get our junk. And what was that? Wow. That was something else. We don't even know where that came from. Line 118. That looks pretty good, doesn't it? 173. Okay. So what we're going to do is we're going to unplug this. We're going to plug it back in. I was just telling you how you wouldn't get unexpected behavior with that command that we sent. Okay, so now let's run this and see what happens. Okay, so we have got an error here. And the error would be up here in the OLED. So what did we do that upset the OLED? You guys tell me, because it's not obvious to me. So we have display fill. And what does it say? It didn't like line 118. Text. That one was a hard one. That really scared me because I thought this thing should work. So did you see my error? Okay, so now let's see if we can stop this thing. No, I think that we've got that second thread running, so we got to unplug it and plug it back in to kill the thread. Now let's stop this and let's run this thing. Okay, there is that command. We sent it. There is our junk, and now we are updating here properly. That all looks good. We have 6 satellites, and now I'm going to switch over here so you can see things better. And let's look at this. So what we have is Ultimate GPS. We've got the date, which is right. We have my local time, and that is right. And then I have lat, and I have lon, and I have satellites, which are all updating. Now, the moment of truth, we come in and we crashed. Okay, so that was line 125. So we've got a test. How did I do that twice? Oh, I copied and pasted it. Okay, right. I had this I copied and pasted so it was test as well. So since I copied and pasted it, that has to be made text. And now we know that we've got that second thread running, so we've got to unplug it. And so now we are going to stop. We're going to come over here where you can see the whole thing. We are going to run it. And I've got my junk. And now the thing is running. Okay, so that looks good. Moment of truth. We press this and we died again. Okay, so let's come back over here and see what our error was. Display OLED. And line 125, 173, it still doesn't like line 173 to 125. Oh, DSP. How did I make all those mistakes? Okay, I think we've got it. I got in a hurry there, didn't I? I bet you guys were yelling at me as you were seeing my mistakes. All right, so I'm going to stop. I'm going to run it. Okay. And now waiting for a fix. Oh, I lost my fix. There it is. Hey, well, at least it shows that part of the program is working. I lost my fix and then I came up quickly with 8 satellites. We're going to come over here again and we're going to watch the moment of truth. And the program has died again in line 130. Man, my goodness, I cannot type today. Okay, one more time. Unplug, plug. We'll go to this view. We will stop it. We will run it. Okay, that's looking good. We've got our data updating. Yep, the time is updating. Everything is updating. We'll come over here to this full view. This looks good. We will come in here, button 1 triggered, and look at that, boom. Now what are we seeing? We are seeing the date. We are seeing the time updating. We are seeing our speed in knots. We are seeing our heading, and we are seeing our altitude, okay? Let's see if we can go back. Boom, no bounce, perfect operation, boom. Back and forth. Okay. Guys, this is a pretty big deal here. Look at this. You've got your own little GPS tracker. And what you can see is you've got all the information off of the NMEA sentences. Just took us 11 classes to get here, but I wanted to do it step by step so you guys would understand how this thing is working. Okay, so what your homework assignment is just basically get caught up if you've gotten behind, get back, kind of get everything working up to the point that I have it working. And then I'm thinking next week, I'm not sure, I might either come in and talk to you about all of the commands that you can send, all the commands that you can send to the GPS to configure it differently. You can change the baud rate. We could suppress some of those NMEA sentences if we wanted to. We could make it report faster or slower. There's different things that you can configure, and at some point we'll do that. But probably next week I will be talking to you about running remotely with this little bread vault. And so if you guys have not ordered your bread vault, you need to go ahead and order it, because what we want to do is we want to talk about coming in and putting this thing on here and powering our project using the battery. Okay, don't do this if you don't know what you're doing, because these 3 pins here that are on the end, which are the V bus, which is the voltage coming from the USB, the V system, which is the voltage that the thing is running at, and then you come over here to pin, like it's the 1, 2, 3, 4, the 5th one over is the 3.3 volt out. And then on this, we have to configure it, or where should this be set to 5? Where should this be set to 3? And so we got to kind of think carefully about how we configure this thing. So don't just run in and plug it in and turn it on. We've got to be very deliberate in the way that we power this thing. Okay. All right, guys, I hope you're having as much fun taking this class as I am making it. It is at this point in the class that I always give a big shout out to you guys who are my Patreons, standing with me with financial support. The only way that I can continue to make quality in-depth content every single week is with the supporters of the Patreon. So guys, thank you very much. You can also help this video by leaving a comment down below and giving it a thumbs up, giving the video a thumbs up. That will help me with the old YouTube juice. If you haven't already, subscribe to the channel. And when you do, make sure that you ring that bell so you'll get notification when future lessons drop. And most importantly, share this video with other people, because the world needs more people knowing where they're going and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.